Thank you for coming. When we talked about this session, the idea was to just talk about how RAG would play into the modern agent world. But there are a few things which happened in the meantime. So let's constantly, update what we do. I'll try to keep this like interactive. Show you some demos. If the internet fails, then you know what's going to happen when you run AI applications. I'm Dobrin. I'm an app architect in Google Cloud. I work with customers primarily in North America. My focus is on performance optimization, serverless architecture, event-driven architectures. And in the last couple of years, I spent almost most of my time in the GenAI space. I go to speak at some conferences from time to time. DevOps. I was at Spring I/O last month in Barcelona. The talk came out today. If you're interested in seeing the Agentic RAG talk, please watch that. Here are some opinions from how I see it, from the work I do. I work with customers who are already running Java and Spring AI applications in production. So let's start by just putting this notion to bed that you have to build AI or ML applications in Python. It was, or it still is, the language of AI ML, but in the enterprise, Java is the dominant language. And if we have invested our time in the past and energy, and our enterprises are building Java applications, there's no reason for us not to be able to add to it. So first, let's just settle the idea of what the distinction between workflows and agents. So first we want to create a distinction, and then we're going to mix it all up. So I see workflows as systems where tools or LLMs are orchestrated through predefined code passes. You know the state machine, one step leads to the second, and that's quite clear. Agents, I see them as two, and this is my personal opinion, as systems where the LLM will dynamically and autonomously direct its own processes and tool usage. So it retains control to a goal we set, and it retains control over how it will accomplish all the tasks required to achieve that goal. And reality will show us that sometimes we have to mix and match between them. That as a distinction, workflows versus agents. Now, how would agents work in an environment? Agents, and we put them in this bubble of autonomy, have to perceive the environment and the human input which we give it, work towards the goals we set, act on the environment to accomplish the different objectives, and then constantly learn from experience. At its center, there's always like a decision-making component of how we process info, how we evaluate options, how we select how it selects the actions which it is going to take. So if we look at the key characteristics, the first thing which comes to mind for an agent, it has to think. Well, that's a relative term, what thinking actually means, but it has to process info and analyze the environment. Then plan, it has to create the strategies to achieve the goals we set out efficiently. Act to take action to change the state of the environment. And last thing is reflect, evaluate the outcomes, learn from the environment, and constantly update. Now, how did we start with agents? Well, the term agent is maybe a little bit conflated here. We started with LLMs with prompts, very clear use case. Here's an LLM, there's a prompt, we get a response. Then we wanted to add additional data, like our enterprise data, which models in their training did not capture. So we added retrieval-augmented generation. And in the end, we realized that we might need different functions to perform different, from mathematical calculations to interact with other systems. So we added actions, as in function calling. But that's not that these are very clear and predefined passes. But in the agent space, we want to have multiple tools, but we want to have a reasoning loop. And then we want to have also agents to talk to each other. So what capabilities do we expect? First, we expect planning to create and evaluate like a multi-step sequence of action. A sequence of action which we might not be aware of. Then run through a step-by-step reasoning process to break down these complex tasks. Identify different functions which are made available, or tools to it. The term functions or tools can be generally used interchangeably to complete tasks. Then reflect on the process and the performance it achieves, and then collaborate with other agents, or it might collaborate with web search engines or different databases or data storage. Now, what type of agents do we see? The first one is, these are the true agents. An LLM-based agent, which by itself we provide to it tools, methods for evaluation, and we set a goal, and they will act independently. But in reality, many times there is this combination of workflow agents, where yes, we want agents to work independently and autonomously, but many times the output of one agent might influence the actions of another. So while the agents themselves would work autonomously, there is still a coordination between them. Now you can execute processing it sequentially or parallel, or have take conditional actions, or in a loop. But here's where this line gets a little bit blurred. So the combination of a workflow with an agent. The last category is like custom agent, where we have custom logic in the code, and we literally drive everything through code. Now, how can we execute these actions? We can have sequential flows. They're tasks which we can ask an LM to decompose a goal into tasks and execute them sequentially. The demos we run today will run sequentially just so that we can see them working one by one. But you can run them also in parallel. If you have dependency-free steps which you can execute in parallel for performance reasons, you can do so. You can take also conditional action. An LLM might decide, and with LLM routing, to take one or the other path. And the last one, which we would look at, is an evaluation loop. Each LLM call will provide an answer to us. That has to be evaluated, and we have to decide, has it reached all the steps to achieve its goal or not. So how should we go about them before we get into each one? So I've built this little application. Consider it like a Swiss Army knife for trying out different LLM tools, or like a postman for LLM. I built this for Google Cloud Next in April, but I kept adding to it. So I always want to understand how things work, how different functionality works, and be able to try things out. If we just build one application, maybe it's harder to maintain. Not that this is simpler to maintain, but it's the idea that we can easily plug in additional functionality. So it allows us to, it's built in on top of Spring Boot with a Vaadin UI, Vaadin Hila UI, and runs on, this one runs on Java 21 or Java 24. Now, you can select different models. These are the latest Gemini models which Google released last week, including the latest flashlight, the super fast flashlight. Allows us to change system prompts, but also toy around with capabilities, with tools, with RAG, use LLM agents, use the agent development kit, use web search, deal with different ingestion method as well as retrieval method. Filter in an enterprise filtering will be important. This deals with world capitals, and all the data comes from Wikipedia. It's the data of all the capitals in the world. So no, there's nothing about Toronto here. We also want to be able to evaluate RAG and then add new features which are coming along with models. So it is not a chat bot, but it's in the form of a chat. So we can ask it to tell the usual, tell me a joke, and it might tell us that it's a world capitals assistant and might not be able to do so. Or sometimes it decides to actually tell us something. So let's think about it. Let's take them one by one. So we have our model. The model has a training cutoff date. What do we add here to build our applications, to build our agents? First, we'll take function calling. I'm not going to walk you through slides. I'll rather show you things in a demo. So if we're looking at functions, a function should, we register them as tools. Spring AI makes it very easy for us. And what do we want? We want to take different actions which could augment what we're trying to do. So if I'm going to, I don't remember, and I'm not going to type them all, so I'm going to just copy them. So let's see. First, we want to try tools. We want to see all the functions which I can call for, let's say, in this chat. And I say present them nicely by category. So whatever we have registered, these are tools which we know about. They are registered and they're grouped by various categories. And I'm not making a distinction here between plain tools, MCP clients, or A2A clients. So we have functionality about weather and climate, travel, currency. We're dealing with world capital, so we want a number of tools here. Some are in our domain, some are in other distinct remote domains. And different utilities. If we go to Germany, we might want a brochure translated into German, or we go to Paris, we might want a French version. So how do we engage with these tools? We can decide, I want to see, let's say, what is the temperature in Berlin. This would call an MCP client, which is registered with this chat model, and would connect to an open Meteo. It generates, it gets us real-time data. It tells us that, what is it, like 22, it's like a few hours ago, like Germany 6 hours ahead. At 4:45, it was 20 degrees. But we might also want to see, like, find a brochure about Berlin, which might allow us to call some other service, but they are totally different services and these tools would give us access to them. Now that's one thing. So let's park this one. When we look at our models, and we know they have a cutoff date, usually they are published, sometimes yes, sometimes not, we don't know exactly. But if we look at data, let's say we're going to ask which athlete won most medals at the Paris Olympics. So this version of Flash says, well, you know, they're scheduled to be handled there. What should I do? Can I ground my search? Can I ground this prompt with some web search? So how about if I enable web search, which all Gemini models support, and I'm going to ask who won. Okay, this is remembers the chat history, so let's clear the chat history and ask again. So which athlete won most medals at the Paris Olympics? And now it tells us this Chinese swimmer won 6 medals, and it tells us about some others. So that's our second tool in our arsenal, augmenting our searches with our prompts with web searches. So now we have tools, but these are actions. And we can have web search, but how about we need enterprise data? So we have data which is, we're all working in various industries, and we need access to data which is not public. Now, access to timely data and private, not just private, but timely data, it also depends on how often we update that data. If we work in a bank and we run a batch every Saturday night, then it's valid as of that particular week, for example. So how does retrieval-augmented generation work? Last time when I was here, we were talking about different RAG methods for chunking and retrieval. It is very important for us to know which method we take. If we take a document, and I take all these Wikipedia documents, I just split them by 2,000 characters. For Berlin, it says 3.85 million. If it chunks it by 3.8, does it mean it's 3.8, or is it like a 5, or if it very much depends. So different chunking methods would give us different results. There are some where we take paragraphs and we add paragraphs before or after. By this we have overlapping windows, but we might find close context. Or we might have hypothetical questions. Let's say chunk by paragraphs, but we ask an LLM, hey, generate some questions, 10 or 20 of them. I generated 20 of them for each one of, for what you would ask me about this chunk if you see it. This should give us better results. Another one would be a contextual retrieval. I take this chunk and say, well, generate a summary here, but based on the entire document. Where is it situated in the entire document? This is great, but it requires LLM calls for every single one of the chunks. Late chunking would be more efficient. It fails right now because the embedding model has changed last week, and I couldn't change this in the meantime. Now, on the retrieval side, when we ask a question, what's the capital of Germany and what is the temperature? These are two distinct questions. So with query compression, we can ask an LLM to generate a single question which would be understandable to an LLM. Let's say, and we'll try it out here. Now, we can also, when we get information from which is stored in vector databases for RAG, we're going to search. We take our prompt, we embed that, we generate a text embedding of that prompt, and we search in that vector database. Okay, so far so good. We have to be very careful. The model we use for embedding is the same model we have to use for retrieval. If we change the embedding model, we have to redo all our embeddings. They're close, but they're not the same. Now, when we get this data, we're looking at vector databases that here's a vector, numeric set of numbers. Which one is the closest one in the vector database? But the closest in the database might not be the closest to our prompt. So if I'm asking what is the current population in Paris, I want some information as closest to my query. The RAG search might give me some numbers, and we want to try this out. But what if we re-rank them? We use a scoring model afterwards to say, well, from what you have retrieved, tell me which one is actually closest to what I have. That should improve the quality of the data which I'm going to provide to the LLM to make a decision. So let's see if we take this particular prompt, and now we're going to enable RAG, and let's say we take hierarchical chunking, and for speed we take, for example, Europe. So I'm asking two questions here, and I get this answer. It retrieves the top 5 by the closest data, by the closest distance. Now, how do I know how this was syncing? So I've built in functionality here. I really like to use this, where I'm asking, once I retrieve the data, I'm passing to the LLM and I'm saying, please add this at the end of your response, so that I know how it was syncing. So it says I got 5 data points, great. Here's the distance, 0.6, 0.6, 0.3, not that bad, but could be much better. We see the embedding and we see the actual chunk. Well, can I do better than that? Well, how about if I'm going to add also query compression? I want to see not just the response, but I want to see how it generated this data. As we build our applications, there's no hard and fast rule. Everything depends on the application we build with the data on top of which we build. Did I chunk all these capitals into 4 different ways? Sure, you're not going to do that in your enterprise, but you need to have a representative data set to see what is most appropriate for you. In the past, when we would write into a CRUD application, create a person, retrieve a person, update a person, that's great. But in here, there are a lot more factors which come into play. So if I'm looking at the source data, should not have made it scroll all the way to the bottom. So it says, this is the query, the original query I generated. Well, why did you not change this? You see, LLMs are non-deterministic. So many times we ask for something, might not always do what we ask. But what if we add re-ranking to it? I want to get those 5, but I want to see how a scoring model would rank these questions from the data which I have retrieved. All right, so it would, what does it tell us? It tells us, you see now query compression works fine. What is the population of Paris? Because in the end, that's what I'm actually asking. So it tells me I got 5, but re-ranking got 3, retained 3. And you specify a level for a re-ranking. That's something which you would be testing. I set it at 0.6, just so because I have data plus minus in the 0.6 to make it, and I can tweak that. So the re-ranking score is at much higher. So it found this, which is at this distance, and seems to be closest to what I want, like, January 2025. Other data might be, re-ranking might bring better numbers, others might not. So we can get our data, and we have to establish the method which we're going to use. So what is virtually next? Like, test-driven AI development. We have all been doing test-driven development, right? You all write your test, unit test before you write code, right? Absolutely. But what does it mean in the AI world? So the team at Vellum came up with this. I like this slide they put together on test-driven AI development. So you want to plan, you want to define the problem, and we're going to ask model to tell us also how they think. Experiment with across different models, different prompts, and different workflows. Then you want to evaluate, but when you evaluate, you have to define now metrics. It's not 100%. If I create person Dan, I retrieve person Dan. Here, if I creating what is the capital of Germany, the response might be a word Berlin, or it might say the capital of Germany is Berlin. Now, how do I evaluate a test? I might just say, does it contain the word Berlin in my test? So it's a slightly different way of how we think about it. Then we want to deploy requests in production, version control things, and observe data. And the data we get, this feedback should be looped back into the production database. We don't do that with tests. We run tests, we run our test suite, it succeeds, great, we move this forward. In the AI world, slightly different. So if we have an AI service of any type, and we have an LLM, deals with a prompt, we want to evaluate it. These evaluations can be done with an evaluation LLM or with specific frameworks. But what is important for us is the metrics which we're going to define. Because we might be looking for context relevance, or detect hallucination, or coherence, or what is the actual factual accuracy. But we have to compare that with a data set which we know is, I don't want to say the golden data set, but a data set which is acceptable to us, and generate evaluation results. So if we want to take a simple test here, let's think if we take the same question we did before, but instead of going through each one, I don't know which one is the best. What if I can evaluate the RAG data and I can say, go and take this question and give me the data for each one of them. And then I can make a decision. Maybe I should have run this first, but you know, I tried one, I was like happy I got some result, but are these the best? So as I'm going through them, well, this gives me a 0.6 distance. Well, I've seen this. What is the next one? Hypothetical questions. Great, but brings it down to 0.42. Is this in the end the right answer? And contextual might be better, might be worse. I've updated it quite recently. Okay, not as good. But maybe I don't like this because I want to re-rank. The data, and I want to see now if I evaluate across all the methods. And then I'm going to have to try this out, and you all have to do this as you build your applications. So we know the first one, great. It retained a 2. I changed the threshold here just to get slightly different responses. The second one and the third one don't even meet the re-ranking criteria. So now I have to make a decision. Am I happy with that data? Am I not happy with that data? How should I think about it? Now, if we want to combine RAG with function calls into an agent, let's build our first LLM-based agent. So I'm going to ask it about a report about the population of Berlin. I used the example of Berlin last time I was here, like 6 months ago, and I'll use the same. Its geographic situation and historical origin. These are different questions, and I'm actually going to run a few more. So I want this agentic assistant to identify the topics, create questions, search in the database. For each one, generate a little summary, collect all of them, and then give me just a final response. So I'm going to use an LLM for 1 to n topics. And then I'm going to ask it to do RAG search, and I have to pick here one of the chunking methods. I picked hierarchical questions. Now that I'm at this step, I now know what works the best for my application. So it will generate a number of questions. Each time you run it, it might generate different questions. They're LLMs. And it's not going to ask 3 questions. It might ask 3, but it might generate maybe a lot more. If I'm asking also about the origin of the city, what does it mean when it was founded, or when it was founded in its current state in Germany? And then I'll call a separate assistant to summarize it. Here I can use a separate model. So I wired in the latest flashlight. Why? I just have a text. I needed to summarize it, do it fast, do it efficient, do it super cost effective, as quickly as I can. And I want all the responses back, and I wanted to aggregate all the responses and provide them back to me. So let's reset our app a bit, and I can change the prompts. What? Widgets. God, what is this? Okay, if I would know what this would do. So how about I'm going to change this the system message here. And I'm going to set the same questions which we were just looking at the slide. Think step by step. We're trying to guide it how to think about our questions. But if we're looking at things, let's take a more complex scenario where we're going to ask it multiple questions. The geographic situation, historical origin, currency use, exchange rates, find also an article in the archive. I'm going to go to Germany. I'm not going to Germany now, but if I'm going to go, I might have these questions. I might have never been there. But what I want, yes?
So just to clarify, so your agent will first generate that list, because you showed us the list from the previous question. So the first step is to generate the list of sort of research topics, and then to go.
Yeah, that's a look at the last part of the prompt.
Okay.
Before proceeding to call any tool, return to me the list of steps you have identified and the list of questions you want to ask the tools available to you. That's for me the most important thing. I want to understand what tools it plans on using, because I want to understand its thinking process. So I might switch the model and use Gemini Pro for this. I can use any model, but let's use the most powerful model I have. I'm way more interested. I've tried function calling, I've tried RAG. I kind of like know the questions, the answers I'll get. But this is a complex goal which has multiple tools. It will call also MCP tools to get me the currency. I hope I didn't exceed the numbers of calls for free currency exchanges. So it will tell me now, I'm not going to pay for that, just for to use that. So here's the plan. Identify the key topics, right? So it's step by step. It generates a number of questions. Okay, so here it identified the topics. Then it devises the question for each one, whatever the number is. Then currency, what's the currency in Germany, and the exchange rate between the US dollar and the euro. This site has accurate data only between US dollars and other currencies, so that's what I'm using. And then I'm going to find a title in the archive. Every tourist bureau has some brochures and so on. So I'm interested in getting this information rather than actually executing it. Now I can execute this, and this would take a bit. Now why would it take a bit of time? Because I'm asking it to go sequentially. I'm asking it to go sequentially, and now it will start executing them one by one, tool after tool. Christian from the Spring AI team actually built separately, so I'm not using any agent framework. He actually built samples of how to call sequential or parallel. Very nice piece of code. Here I just let the LLM decide which calls it's going to make. I'm not touching this in any or influencing it. So I get the geographic situation. Yeah, I asked about it. Historical origin. Okay. I get the population of Berlin. Here's the currency and exchange rate. So it's the euro, and right now it's 0.93. I don't know. I have to trust that this is accurate because it's as of today. And then here's an archived article, which was published sometimes in 2008. And because it's large, these are like several K or so long, I'm just getting a summary of this. So I let the agent think about what it has to do. That is important to me, and I can understand how it is going to work and interact. Now, we looked at, if we start from the beginning, we looked at tools, we looked at grounding with search, we looked at how we can have data, we looked what an LLM based agent would do. However, there are different ways in which we can run this. So let's reset our app so I don't reset the settings. Sometimes we have this data, but we might need additional data, tools and context, which we don't have available, and sometimes we just don't know about. So this is where MCP came in. It was launched, it was built by Anthropic, and the Java implementation was donated by the Spring AI team. So that's what we're going to use. So when we built an application and we had REST services connecting to various backends, we had kind of like an M times N problems. Have a client for each integration, and each one had its own ways of being built and its own quirks. But what if and each one needed its own tool or key to access. But what if I use this analogy? I like these diagrams where I have the equivalent of an of a USB port for AI applications. Here's my server, and I can have a number of clients, but I have a uniform way of expressing it. What would this allow me? It would, generally, you're going to see oh, MCP and tools. You're going to hear that in the same sentence, but it's a lot more than that, especially for us when we build applications in an enterprise space. So an MCP server would expose some tools which a client would call. But it also exposes resources. We might have a legacy database, and we might just expose that as a resource, or a file system. We might have some, or we get reports somewhere. That's fine. But we might also build prompt templates, good quality prompts, which are made available to us, so that when we build them, we can use them. We also want to be able to evaluate them and preview them. So it's not just tools. It's resources and templates as much as it is. Then with MCP, all these servers are not necessarily smart. They might just do some data. And sometimes they might say, look, I want you to do something for me. Well, if I get the climate for a certain city and it gives me a climate on 10 pages, I might not want to return that. So I want to use sampling, call back the LLM-based application and say, can you actually summarize this for me? Or can you do something for me? The word sampling is a little bit, I don't know where this came from, but doesn't matter. But this is what it would help us. And then we can expose also roots of a file system. Now, you've heard of, or you have seen all these code-assisted tools, and you see all these tools, they run local MCP clients. That's fine, it's a perfect use case. You can do that with your applications. I see more in the enterprise, and I can see from what teams are building, I see remote servers, because a server might be on another machine, it might be maybe in another system. As long as I can have access to it within my network, I'm good with that. So in the transport which you can have available, you can have SSE, it's stateful connections, and that was the original in November when Anthropic published the spec. In March, and the spec has been updated several times since, in March they have added also stateless connections. So that's something which everybody wanted. And the latest update from like a week or 2 weeks ago has added now security, because their security was missing as a whole from... which one? I'll compare MCP with agent to agent, because I think it's going to be maybe more relevant. What we want to know is that with MCP, soon once frameworks catch up and implement this, we will be able to use Playmation.
I'm kind of curious, I mean, because we try to kind of retain the context, right? So without state, I don't know how to use it.
No, you would still be able to use SSE if you would like to. Of course, it's just an additional thing. Most teams I work with, or I'm talking to, are looking for stateless connections with MCP servers. But again, you would be able to continue doing whatever you would like. Now, what is the life cycle? And it is quite chatty. We should know about that. We initialize a call to a server, request a session its capabilities, it comes back and says, okay, here are my capabilities. And then we send a notification, okay, the initialization is complete. Then we do whatever we want to do, interact with that server, and in the end we have to gracefully disconnect and close that session. Now on tools, we request a list of tools, we get the tool list, and then we decide which one we wish to call, and we get a response. It works in a similar manner with prompts, and as well as with resources. So interface is quite clear, and we can run this. But one thing is very interesting. I might have an MCP client which might expose some functionality on the server. My app is up and running, it doesn't have to go away, but the MCP server might add additional functionality. One app which Adib started and we have used many times in sample is that quotes app. So get quotes from a database by different things. So we can add various things, by author, by book. What if there's a quote by author, and now I want to add a quote by book name? I can change an MCP server and issue a notification. If the client subscribes to it, I can get a list of updated tools and my server continues working. That is going to be important for us as we're thinking about distributed systems with a lot of moving parts, and they're also changing. With sampling, it's as we discussed, a server might tell a client, hey, please do something, create this, it creates a message, please do some operation with me and for me, and I can provide some hints. Maybe use a specific model, or maybe don't return me anything past 10,000 lines, or whatever this might be. You get a response, and then the MCP server can incorporate it. Now, let's see how MCP works. So I want to see first, I see all the tools. Let's run this one more time. Let's use now this model. And we want to enable tools. We keep it simple. So it will give us all these tools, weather and tourism and various things. So I see this weather server. So I'm going to say, I want to list all the capabilities, because capabilities would include all three prompts, tools, resources. So I want to see all the capabilities, and it will give me a set of them. But what if I want to distinguish between them? So I'm going to say list all the tools for me. So here are the tools. One is a get a climate by capital. The other one is get a temperature by location, which we tried. And we can also get the temperature by capital name, or the latitude and longitude. All right, so this is fine. But what if I want to see only the prompts in here? Because we ran this before, so I want to see what prompts are available to me. Of course it has. This chat history. You see, this is the perfect example. This is not a production application. Don't take a demo to production. I'll list pitfalls at the end, because I hear this many times. My demo works well, but not in production. So here are some prompts. If I want a prompt for a detailed weather forecast for how many days, or a climate overview, or a weather comparison, I can get all these prompts. But what if I want to actually preview them? So let's see if I'm going to say preview this weather comparison. What do I expect here for weather comparison? Where is it? The first location, the second location, and a time frame. Let's say current. So see how the weather is in between them. Okay. Vaadin released a new version, and I did not update this yet. Fine. So we'll just reset the chat. So it will generate this prompt. Here's a description, and it will tell me how a user prompt should look like. You're a weather analyst, compare the weather, focus on the current conditions, and then I can execute that. But this is a good prompt, which is known, especially if you would build like a customer service app, or you build maybe a medical system where you might want the right questions to be asked. And we can run it, we can try a different one. Also, if you don't know the answer to this, then, what's the climate in Ottawa in the winter? I don't think there's too much to debate here about it. So think about MCP.
How do the prompts and the tools interact?
So tools are just going to act for me, are just going to interact for me. And prompts are just, I'm going to define these prompts, which I can use, which I can provide. So here's how a good prompt should look like. And then when I send it to the LLM, I want a tool to pick that up.
Oh, to pick the prompt.
To pick that prompt out. But by having it generate these prompts, I want a better prompt. We as humans try to write the simplest thing. Tell me what's the difference between Paris and Berlin as temperature. The more explicit we are, the better the results. The way we phrase things, the better it is. Same like a human language. If we work together and I'm saying, give me a code review of this class, what is it like? Just have a look at it, or do you want a detailed code review? if we work for 5 years together, then maybe we know that. But if we meet the first time, what is it that we're going to ask, right? So it allows us to combine this. Now these servers are all running. I can run them in. I run them right now on my machine just so that I can show you logs. Otherwise, if I look into the cloud, then it's a different thing. But the same app runs in Cloud Run serverless, plain deployment. Build the image, cloud native build packs, and have this deployed. Now, we like this, we like MCP, and we always hear about it within our domain, especially as security was not there. But then let's think about the collaboration across domains. So if I have my tourist agent and I have these tools in my domain, and here are the world capitals, I have a root agent. And there are a few little agents which will work for me, like a tourist bureau, another one for currency, some for weather forecast, some are servers, some are not. But what if I want to, I like to go to Paris, how about I want to find maybe an Airbnb? And what about if I don't know maybe French, maybe I want to write some text or get a brochure, have it translated maybe into French. These are separate domains. In an enterprise, they could all be different lines of business. I know microservices broke down the barrier, right? But they're separate security domains. They could be agents doing independent things. And we want to see how we can do that. So Google launched the agent-to-agent protocol, which was made available at Cloud Next in April, and for this purpose. And on Monday, it was donated to the Linux Foundation with support from all the hyperscalers and around like 200 different customers. So now it's it's open. It will evolve as such, and it's supported by every large company we kind of like know about. Now, what does it mean for us? When A2A came out in April, there was no, it was just a spec. Here's a JSON spec, you use it, it's there. But how about SDKs? We don't want to build our own client and our own server. It's not like in the open API specs where we do contract-driven development and it's mature and it's very clear. We generate a consumer of a service and a provider. So there was only a Python SDK, and on Monday, the Java SDK for A2A was made available. The initial contributors here are Red Hat and Google. It is available now. You can you can create issues and send pull requests and contribute to it. So I'm going to show you today the very first demo. This has not yet been shown. It's going to be probably public only in blogs like tomorrow. But I'm going to show you the first demo. I finished it actually this morning. So what is the difference here between, from MCP to A2A? So A2A has the concept of, from the beginning, of supporting agent discovery. It's secure by default because it has authentication authorization mechanisms. Sure, you can secure an MCP server, and Daniel from the Spring security team built a very nice sample, but you build that as an app security. Here, it's built in the spec. It focuses on collaboration between agents, not just tools. Standard JSON RPC. It's modality agnostic, text, video, audio, not a problem, and you can run shorter and longer running tasks. Now, what is the difference? I see MCP as connecting agents and tools, and A2A as agent-to-agent collaboration. Because with MCP, we want to connect agents to tools and APIs and prompts and resources. And between agents, we want an open standard supported by the community, which should allow us dynamic and multimodal communication. Agent development frameworks are emerging now. Google launched the ADK, the Agent Development Kit. There's also an open source one called Mbabel, which is was started by Rod Johnson, the Spring creator, which is also, you can see that in the news. You don't need to use an agent framework in here, but what you can do is just understand the right differences and see how you build your own applications. Now, everything starts from discovery. So the actual, each agent is described by an agent card. Think about it like if you look in at Hugging Face and see all these models, each model has a model card. If you look in Vertex, you can see all these models and they have an agent card. But this agent JSON is mandated to be at a location, and it has to have a public endpoint called .wellknown/agent JSON. By this, every agent will be discoverable at that location. You have the URL of a service, you can access that. What would it explain to you? Where it is to be found, who the provider is, the version, the authentication scheme, here it's OAuth 2, the different modalities you interact with, and then the different skills it can do. So for example, I'm going to try and see if I can make some reservations for a hotel tomorrow in Toronto on Airbnb, I hope. So it lends itself to this interesting combination. If agents are remote, why don't we build an MCP server which would act as a discovery mechanism? So we can discover different agents by exposing them, building them into an MCP server, which could dynamically be updated, and then have an MCP client. Registries for agents are emerging. It is early days in this space, but we have to start from a mechanism which we are aware of. So differences, theoretically, we can call simply different operations remotely as an agent, but the MCP did not have dedicated auth, so it will be implemented, and no specified discovery mechanism, whereas A2A brings that out of the box. So let's see if we reset this and we try and see what agents we have. So if I'm looking at an agent, this is a travel assistant, I'm going to say, can you please, are there any agents available to you as my travel assistant? So yeah, there are a couple of them. One is a translation, and the other one is an Airbnb one. So we were getting these brochures. So how about I'm going to say, what's this? I don't know what this is. I'm going to say, find an article about Berlin in the archive. Before sending it, translate the article from English to German and send both in a single response. So I want to see this invoking. So it retrieved this with MCP. Here's my article, and now it's going to call a remote service and translate it to German and return both of them to me. So these are separate. I'm using a different agent which runs remotely. But how can these agents be built? So if this is a Java app, do the A2A servers have to be built also in Java and also with Spring AI? So that server is built with Java and Spring AI. But what if I try to get one connect to one which is a Python server, and connects to Airbnb. Via that agent connects to an Airbnb MCP server, which I have available. So polyglot interoperability is very important to us, because now that we have a way to talk to each other, I need to be able to access a service. It could be in a different language. So let's see, where is our server? So it will take its time to find. No, that's, okay. So this is where we are. Maybe that's not. Where's my app? So it found several options for me to check in tomorrow, from different rooms from North York to different locations, and it gives me also links. Last time I tried out earlier in the day, it had more availability. Maybe long weekend was coming up, so I can interact between services in different languages, built in totally different ways. Now, on where is my? I wouldn't mind finding my. So, different agent development toolkits are emerging. Do you need to use them? I would say use them only if you have to. If we started from REST APIs, we started adding LLM frameworks, the Google GenAI SDK, different SDKs. Then we added low-level orchestration frameworks, Spring AI, LangChain4j. And then we have now agent frameworks, which would help us coordinate between different agents if we need that or if we choose that. And the last one would be no-code platforms. Now, if we talked about different agents, so we looked at LLM-based agents, but what a toolkit like ADK would give us, the ability to build workflow agents, talk to different models, execute and define workflows in various ways. And we can have hierarchies of root agents talking to different agents here. It's open source. It supports Gemini models or other LLM models via the Light LLM interface. You can deploy them anywhere on your machine. If you containerize them, Cloud Run, Cloud Functions, GKE, wherever you can have a standard container, not a problem. Or there's a new offering of Google Agent Engine, which you can run. And you can build a flexible orchestration, have session management, and as support out of the box for MCP and A2A. This is new. It was released in the Java version was released at Google I/O May 20th, which is like a month ago. But you have options if you need them. So rather than showing ADK, now let's go through what we would need to think about a platform and also some pitfalls. Nothing works easily or for free. We always have to keep a few things in mind. So if we start simple, here's a user has an LLM, great, it's a response. We want to add now RAG and agents and get access to read-only actions and vector databases, could be file stores. So we need to add to the context. But we automatically have to think about guardrails. We don't want PI data to leak. We don't want inappropriate questions to be asked, but we also don't want inappropriate content to be generated. It's very hard to control who has access online. We're all adults, but we don't know if somebody takes a hold of your laptop and gets some inappropriate content. Now, we use LLMs for generation, for scoring, for routing, for evaluation. We looked at that. But we also have to think about performance. We can add caching of requests, because we pay less if we can cache input data. Gemini models added just in the last, I think 2 weeks ago, implicit caching. If you have any tokens over, any prompt over 1,000, I think 1,000 input tokens, and it's similar data, it's automatically cached. Let's say I want to have in my English exam, I had all of Shakespeare's works, 5.5 megs from the Gutenberg project. I don't want to add it for 10 prompts each and every time. I don't even have to explicitly cache it. I can if I choose to, but I can do it implicitly. On the response side, a little bit more complicated if you want to do semantic caching, but super helpful on context creation. I should have added observability before even starting about this, but it's better to see all the pieces. More pieces, more components, we need to be able to observe it, we need to be able to trace it. If we did that for microservices, we have to do that in this space as well. And in the end, advanced features will come into play. Those have to be tested again, and then tested as many times. Do we want to trust our applications to do things like write actions, like send an email on our behalf or update a database? We have to really be able to test this out and think about this through. Imagine if we have to update some medical data. If you have to update some medical data and update somebody's blood pressure from, I don't know, 1 to 2 or 2 to 5, I don't know what the numbers are, you can imagine that might be a serious problem. Now, we can deploy them. I deployed this in Cloud Run. I put just a few of them. You can have your choice of models, how you run them. Never think that this is going to be a problem. If you deployed your services before, you can deploy any kind of applications, and we're in the Java space, not a problem. Now, what are pitfalls? Nothing comes for free. So the first pitfall is like using GenAI when you actually don't need it. So let's not forget, GenAI adoption starts from business needs, not technological aspects. I needed this summarization, and because I don't want large documents, great, I can just add this functionality. It helps me out. But if I don't need that, my application can continue running. If my volume of data increases, maybe I have more documents, I want to summarize them. We all have meetings, we have to run from one to the other, or we skip a meeting. Can I get a summary of it? Great tools. Now, conflating a bad product user experience with a bad AI. Starting to build a GenAI app is easy. We see these super light demos, great. But bringing a good product to production, which scales, because now we have to scale users. We might run an agent which run a myriad of tasks in parallel. That's the hard part. The next one would be starting with a complex solution rather than building an evolutionary app architecture. If you have an app and you need some specific features, build them one after the other. Don't start imagining a system which by the time you finish designing it, there are tools which might maybe doing it for you. So use an agentic framework when using it when simple direct API calls or agent-to-agent calls might resolve our problem. The last three would be being optimistic that an initial demo success translates directly to production greatness. We have to think even more than before on reliability, safety, security. There from day one. It's not just, well, once it's in production, we'll figure it out. The next one would be relying entirely on AI as a judge, as a substitute for human evaluation. We have to set up criteria and data sets, but we have to constantly correlate human judgment with AI judgments, because if they diverge, it's our responsibility. So we have to investigate the AI judge and see maybe data gets out of sync, maybe we have not taken things into consideration. The last one would be failing to continuously evaluate and gather feedback. Models change, model responses change. Feedback changes, data is, we have more users than we thought, or they use it in ways which we did not anticipate. So with this, I'll stop here. Thank you for your patience. And if you have any questions, I'll be happy to mislead you like an LLM.